One of the main differences between this, which is going to look a little like chapter 6, some of those hard fractions we did, the difference is this is an equation, which means it has an equal sign and an answer. In chapter 6, when we were adding and subtracting fractions, there was no equal with an answer, with a variable to solve. You just had to do that LCD stuff. So, first of all, let me start with a simple example of what we'll be doing. So in chapter 6, it might have looked just like this. And you find the LCD, and you turn the LCD, each fraction into its equivalent fraction. The difference here is we have an equal sign with an answer. And so the difference is, instead of just adding or subtracting fractions, we are still solving for the variable. So there's a couple steps here to do this, and I'm going to write them on the right side over here. Step 1 is still going to be find the LCD. The good news is that you won't have any denominators that are binomials or trinomials that you have to factor. At least not today. Okay, that will be Tuesday, we'll see those, but by then, no problem. So for today, you might have variables, you might have different numbers, you'll need to get an LCD, but for today that'll be a little bit simpler. So, what's the least common denominator? Oh, and by the way, you've got this answer here with 10. If you need to put it over 1 to visualize that denominator, go ahead and do that. LCD for these 3 numbers, Carissa?
21.
Okay, so in this case, in this example, the LCD is 21. Of course, it won't always be. Step 2. Multiply each part of the equation by that least common denominator. Multiply each part. So when I say each part, I mean literally each piece. X over 7, x over 3, 10, or 10 over 1. Now the goal of this, here's the good news, is when we do step 2, the fractions will go away. We never had that in chapter 6. We were dealing with those fractions, those really hard, difficult fractions the whole way through. So, let me show you on this. The fractions will go away. Here's what's going to happen. I multiply each piece by my LCD. Now I put the parentheses just so you can see it's multiplying that whole fraction. Our LCD is 21, so I'm going to multiply each piece by 21. Every single one, even the equals, what comes after the equal sign. Now, for this, I'm only going to write this on the first one, but we could put 21 over 1, right? It's a whole number. And if that's being multiplied here, what would I get if I just multiply this piece by 21? Izzy? 21x over 7, right? Now, I'm going to write that down for this, and then I'll show you how you can even take a little shortcut. We would get 21x over 7, right? Can I simplify that? The 21 and the 7, right? Because now, in this piece alone, there's just multiplication happening. I can simplify. 21 divided by 7, 3, right? So, 21 divided by 7 is 3, and what do I have? 3x. Look, no more fraction. Let's try it on the next piece. Now, for this first one, I'll write it out for each one. Maybe on the second example, I'll show you how you don't have to write this middle step here. If you can do mental math, you'll be able to skip this middle step. If I did this, I could put 21 over 1. Notice the LCD is always a numerator. It's a whole number. So it would always be in the top, over 1. So this would be 21x over 3 if I multiply it. Right? And if you're not sure how I got any of these steps, just raise your hand, I'll explain it again. 21 divided by 3, 7 times x, 7x. Finally, this one will be even easier, 21 times 10. So take a look, no more denominators. Fraction be gone. No more fractions. If you multiply every piece by the LCD will simplify that denominator to where it goes away. Really, the denominator's 1, but when it's 1, we don't need to show it. Combine like terms on this one. 3x plus 7x, 10x. Divide both sides by 10. Done. Izzy.
Is that like the hardest?
No. I always start with the easiest. But it's not going to be much harder than that. I'll show you. It's this process the whole way through. So, on the steps over here, multiply each part of the equation by the LCD. Fractions will go away. And then the final step is just solve the equation. So in this case, that meant combining the like terms, right? Undoing by doing the opposite of whatever's there. The solving the equation part, I think everybody's good on. So I'll do another one. I'm gonna do 2 more. Now, let me just show you on this one since we've already done it, and then this is how I'm gonna do it for the next 2. Instead of writing this middle piece, 21 times x over 3, 21x over 3, and that divides. Watch what you could do. If this is a numerator, 21, and this 3 is a denominator, remember that when we multiply fractions, which really is what we have here, you can simplify a numerator and a denominator before you multiply if they divide by the same thing. Both of these divide by 3. Look at what's left. 7 times x over 1. There it is right there. So if you can do this, you can skip straight to here. And I'll show you that on the next one. That's how I'm going to be doing it from now on. If when I do that, you lose me and you're like, wait, where did that come from? Raise your hand and I'll show you where it came from. Okay, so let's do another one and I'll try to show you that little shortcut of mental math. 3a over 5 minus, watch the minus, a over 2 equals 1 over 20. So in this case, I don't have a whole number that I need to put over 1, but that's okay. It's going to be the exact same step. Step 1, LCD. And again, the good news today, just numbers for your denominators. Just numbers. Least common denominator for 5, 2, and 20. CJ?
20.
20. Step 2. I'm going to multiply all of these times 20. Now I do want you to write that part down so that you don't forget a piece. If you forget to multiply, say the 1/20th, that final piece, then you're going to get the wrong answer. Now, here's the shortcut that you could try to do. You could write 20 over 1 and 20 times 3a is 60a over 5. Or, knowing that this is a numerator and 5 is my denominator, 20 and 5 both divide by 5. Divide by 5, 1. Every single time your denominator becomes 1. 20 divided by 5, 4. Now let's look at what's left before we move on to the next piece. 4 times 3a, 12a. Over 1, I'm not even going to write the over 1. I don't need it, 12a. Now I'm going to go ahead and make sure I write down my minus for this next piece so I don't forget that it's subtraction. 20 and 2. Now again, you could write down 20a over 2 and then simplify it, but if you can do the mental math, 20 and 2 both divide by 2. Divide by 2, divide by 2. Don't forget to multiply what's left. On this example, I'm doing it in the brown, so 10 times a, 10a. Final piece, 20 and 20. Oh, they both divide by 20. 1 and 1. 1 times 1 is 1. Right, so again, you don't need to write what I'm writing on the right side if you don't want to. We just multiplied everything times 20. That's my little shortcut there. And now step 3, let's solve it. We can combine like terms. 12a minus 10a, 2a. 2a equals 1. Let's divide by 2. a equals 1/2. Done. not too bad, right? We'll do one more. Any questions on anything I'm showing here and where it came from? Better than chapter 6?
Yes.
Good.
Yeah.
Okay. Okay, final one then. And the only difference here is we will have a binomial in a numerator, not a denominator yet. X over 3, last example, let me move it up. X over 3 minus x plus 2 over 5 equals 2. And anytime you have a whole number, you can put it over 1 if that helps you to visualize to find the LCD. If I have denominators of 3 and 5 and 1, my LCD, Daniel?
15.
Good, 15. So now, again, I'm going to take each piece and multiply it by 15. 15, I accidentally almost wrote the answer there. 15. Now, if you want to use color on your homework, the way I'm doing it here to try to see what's left over, right now when I do this, whatever's left I'm going to show in green. If you want to use color to help you organize your work on your homework, please do so. As long as you're doing most of the work in pencil, if you want to use some pen to organize it, that's fine. All right, let's use our shortcut. 15 is a numerator, 3 is a denominator, so I can simplify. 15 and 3 both divide by 3. Divide by 3. Divide by 3. Now again, I'm using color here in this way so that I can easily see what's left. In my first fraction, I have the 5 and the x. And at least for me, that helps me to see it better. If you lose a piece, if you can't see it, if you write too small, you end up with the wrong answer. So take your time, write big enough to see. 15 and 5, both divide by 5, divide by 5, divide by 5. Now, because this is a binomial and it's a minus, I'm not going to distribute right now. I'm going to come back and do that later. I'm going to write my minus, my 3, and my x plus 2, because we need to be a little careful on that piece. Final piece, 15 and 1. Well, they both divide by 1. Didn't really change, right? On that one, maybe you could just visualize, well, it's 15 times 2. What's 15 times 2? 30. In that case, we didn't even really need to simplify because it didn't do anything for us. Okay, so Izzy, this is as hard as it will get, where you might have to distribute before you simplify. Not hard, right? So let's do that. Now be careful on this, that you take the negative or the minus with the 3 as you distribute. So the 5x I'm just going to recopy so I don't forget about it. Negative or minus 3 times x minus 3x. Negative or minus 3 times 2, negative or minus 6. So just that one extra piece. Be careful if there's a subtraction sign, and be careful if it's a binomial. Distribute first before you try to combine like terms. Now we can combine like terms. 5x minus 3x, 2x. So I'm left with 2x minus 6 equals 30. As always, we leave the variable alone to start. We start by undoing minus 6, by doing plus 6 on both sides. 2x equals 36. And when I divide both sides by 2, I get my answer. That's it for today. Oh, you don't. Oh, go on. Oh, go on.